Hello everyone. Welcome to our AP Chemistry MCQ session. Please like, share, and subscribe to our channel to stay updated. Today, we're diving into the fascinating world of chemistry with a focus on knowledge of everything related to AP Chemistry. This is our first slide, so I just want to give you a quick overview. We'll be covering key concepts, practicing multiple choice questions, and helping you prepare effectively. So, let's get started and make this session both informative and engaging. Let's take a closer look at this table. Here, we're comparing 4 different gas samples stored in identical rigid containers, all at the same temperature of 273 Kelvin. Notice that for containers 1 and 2, the gases are helium and neon, both at a pressure of 2 atmospheres, but their masses are not given. Container 3 has an unknown gas with the same pressure, and container 4 contains sulfur dioxide at slightly lower pressure, 1.96 atmospheres, with a mass of 64.1 grams. The key point here is that even though the pressures are similar for the first 3 gases, their masses differ, and that hints at differences in their molar masses. Since the containers are identical and at the same temperature, the ideal gas law tells us that the pressure, volume, and temperature are related to the number of moles of gas present. This setup allows us to explore how molar mass influences the mass of a sample under these conditions. Also, notice how the pressure for sulfur dioxide is slightly lower, which could be due to various factors like the gas's physical properties or slight experimental variations. Overall, this table sets the stage for understanding how gas properties like pressure and molar mass relate, especially when comparing different gases under the same conditions. Now, let's focus on the question at hand. We are asked to consider containers 1, 2, and 4 under specific conditions. The key point here is to understand how the average speed of gas particles varies in different containers. Remember, the average speed of gas particles is influenced primarily by temperature. So, if the temperature is the same across these containers, their average speeds should also be the same. However, if there's a difference in temperature or other factors, that could change the speeds. The question asks us to identify where the average speed is greatest. So, we need to think about what conditions could cause particles to move faster. For example, higher temperatures lead to higher average speeds. Conversely, if the containers have different pressures or volumes, that could also influence the speed indirectly, but temperature remains the main factor. Considering all this, the most important takeaway is that the container with the highest temperature will have the fastest moving particles, meaning the greatest average speed. The options then are to compare the conditions of containers 1, 2, and 4 and determine which one has the highest temperature or the conditions that lead to the highest particle speed. This question ties into our overall theme of understanding gas behavior and how different factors like temperature and pressure affect particle motion. So, keep these concepts in mind as we analyze each container's conditions to find the correct answer. Thank you so much for joining me today. As we come to the final slide, I want to highlight the idea of knowledge of everything. This isn't just about having facts at your fingertips, it's about understanding how everything connects and applying that knowledge effectively. Please remember, there's more to come, so stay tuned for the next video. I really appreciate you watching and engaging with this content. And before we wrap up, don't forget to like, share, and subscribe. Your support helps us bring more valuable insights to you. Thanks again for being here, and I look forward to our next session together.